Here I'd like to give some motivation for it. And actually, it's a new project we have. We do have a video, a demo of a prototype, because we have an installation of fireware, and we connect it with some sensors, soil sensors, and it's in my university, UFABC, there to the OpenStack cloud. And then we are able to get this information there and to show in a dashboard as well as a simple demo in our YouTube channel. But then I'd like to give some what's the problem with precision irrigation? Farmers, they fear that the plants, they go under hydric stress, and in order to avoid that, they simply spray a lot of water in the soil. And they don't know how much water can be kept in the soil, which is called field capacity. And because of that, they spray water and spray and spray and spray. And so from a certain point on, what happens is that the water starts to percolate, so you just lose the water that they were spraying there. And so people estimate that you lose like 50, 60, 70% of the water. And if you consider that 70% of fresh water in the world is used for irrigation, that is a lot, you know? So this isn't the world. And so, what happens? What do we have to do? First, this is the naked soil. You have to understand the topography, and from that you do a soil electroconductivity test, and then you understand that you have different soil types like clay or rock or sand, and because they have different field capacities, and so based on that you determine that you have different management zones. In these management zones, if you have like 100% of irrigation, in some points you have to irrigate less, and then others you have to irrigate more. Okay, from that point on, what you do, you install sensors in those management zones, one or more depending on the size of the area, to know exactly how much water is available for the plant there. Okay, and based on that, based on your knowledge of the models, of the irrigation models, water need models, and then you are able to generate the irrigation prescription map. And in some tests that they did, they found out that with the using that variable rate irrigation technique, they can get like the same productivity using 50% of the water, and this is good for sustainability, but also is good because you save energy, and the cost of energy can be really very high in that area called Matopiba in Brazil. They have a thing that in the night the cost of energy is 10% of the cost, the energy during the day, and then they tend to irrigate in the night. The problem is that in the night the plant doesn't do transpiration, and so you have to store the water, and so it's a very complicated matter. And in the dry season they have to irrigate 21 hours a day, and so they want to save that because they plant commodities, soybeans and cotton, etc. And so if they lower the cost, they improve their profit, and so this is good for them. So this is basically the architecture that we're considering using fireware, and I like to collaborate if it's people interested in fireware. We're trying to understand if you can like install this in the cloud, and then this is we call it Fog Hub, and how is this relationship between modules installed here and there. And we are going to understand how it works in practice. And that's it. Thank you very much.